Good morning to everyone. Welcome to my channel Hari PS videos. Let's um, like, share, comment, and subscribe my channel if you are not subscribed. So thanks for subscribing who are subscribed my channel, and thanks for watching my videos. And I request you all, always I requested many times, చాలాసార్లు రిక్వెస్ట్ చేసుకున్నాను, ఇంకొంచెం పర్లేదు అనిపిస్తుంది, ఇంకొంచెం మీ యొక్క వ్యూస్ని పెంచుతారని ఆశిస్తున్నాను. సబ్స్క్రైబ్ చేసుకోండి, ఛానల్ని తెలిసిన వాళ్ళకి షేర్ చేయండి. సో మోర్ సబ్స్క్రైబర్స్ రిక్వైర్డ్, and likes, more likes also important. Some of you are just watching the video but not giving any like, or not all making any comment also. So requesting you all, please give a like, make a comment, and share the channel with your friends or relatives. Okay, without wasting of time, today directly we have started our topic. Today our topic is equations of motion. Equations of motion. In the chapter motion, equations. Equations of uniform accelerated motion. Uniform accelerated motion. To describe the motion, we have to use either time, reference point, frame of reference, observer, distance and displacement, speed and velocity, acceleration, right? Then let us discuss the motion of the body by using some equations. So they are called equations of uniformly accelerated motion. We have three equations of motion. Those bodies have traveled with a uniform acceleration. They have a relationship between velocity, distance or displacement, time, and acceleration. So let us derive those equations. First we have first equation is v equal to u plus at. V equal to u plus at, the first equation. The second equation, s is equal to ut plus half at square. The third equation is v square minus u square is equal to 2as. V square minus v square is equal to 2as. So these are the three equations we have. So the first equation tells us relation between velocity time relationship. First one, time velocity relation. The second one, distance time relation. And third one, distance velocity relation. Distance velocity relation. So first equation, v equal to u plus at. Second one is S is equal to ut plus half at square. Then the third one is v square minus u square equal to 2as. The first one is about velocity time relationship. Second one distance time relationship. And the third one distance velocity or velocity distance speed distance relationship. Let's derive the equations one by one. For that, let us assume, let us assume that, let us assume that a body of a body is moving with initial velocity, with initial velocity u. A body moving with initial velocity u. Suppose it is subjected to, suppose it is subjected, it is subjected to uniform acceleration, uniform acceleration A, uniform acceleration A. Let us assume that a body, a body with a body with uniform velocity u, suppose it subjected to uniform acceleration, to that after time t, to that, to that after time t, its final velocity, its final velocity v, and covered, and covered a distance s, a distance s, or the displacement s, distance s or displacement s. So as and cover the distance s. Now derive the each equation. So derive first equation, v equal to u plus at, v equal to u plus at. Derivation of v equal to u plus 8. So we know acceleration. So if they suppose let us consider a body with initial velocity u subjected to uniform acceleration a to the time of after time t, its final velocity v, and covered distance s. So we know that acceleration, acceleration equal to final velocity, final velocity minus initial velocity by time. Final velocity minus initial velocity by time. We know that acceleration formula, final velocity minus initial velocity by time, final velocity minus initial velocity by time. So we can write acceleration A equal to final velocity v, v minus initial velocity u, time t. So we can write this at equal to v minus u, at equal to v minus u. From this, we can write v equal to v equal to u plus at, u plus at. So we derive the first equation. We derive the first equation. Right. So here v is equal to final velocity, u equal to initial velocity, a equal to acceleration, a equal to acceleration, t is equal to time taken, time taken. So we derived the first equation of motion, v equal to u plus at. This equation gives the relationship between velocity and time relationship. Then coming to the second one, here same, again we have to know. Let us assume that a body cover with moves with initial velocity u. Suppose it is subjected to uniform acceleration a. After time t, its final velocity v and covered distance s. Same thing. So for all same, we can write second one, s is equal to ut plus of at square. Deriving s is equal to ut plus of at square. So we know that average velocity, average velocity average velocity equal to we know final velocity plus initial velocity by 2. So if the body covers different have different velocities, so we can calculate its average velocity by its arithmetic mean, by arithmetic mean or arithmetic sum. So final velocity by initial velocity. And also we know that average velocity is equal to displacement by time, displacement by time. From this we can write displacement, we can write displacement or distance, displacement or distance is equal to average velocity, average velocity into time, into time. From this average velocity is average velocity is equal to u plus v by 2. Then displacement is equal to average velocity into time, average velocity into time. So average velocity here same would. So substitute here v value. So let us substitute this equation 2 in equation 3. That equal to s is equal to v into 3. V into 3. It is third equation. Let us assume that. So s is equal to v value u plus v by 2 into t. U plus v, u plus v by 2 into t. So from equation 1, v is equal to u plus at. So substitute v in equation 4. In equation 4 we can write s is equal to u plus v value u plus at, u plus at by 2 into t, into t. Then we can write u plus u, 2u plus at by 2 into t. Multiply this, 2ut plus at into t square by 2. That is equal to, write separately because I has same denominator. So 2ut by 2 plus at square by 2. S is equal to S is equal to 2ut by 2 plus at square by 2. So here 2 get cancelled. The remaining what to have? S is equal to ut plus 1 by 2 at square. S is equal to ut plus of at square. So we derived second equation also. Here taken 4 and then be taken as 5. Then derivation of third equation. Here in this equation S is equal to ut plus of at square. S is equal to distance or displacement. Distance or displacement. U equal to initial velocity. Initial velocity. Then V is equal to final velocity. T is equal to time. T is equal to time taken. Then coming to the third equation. So hope you did understand the first and second equation. First and second equation. First and second equation. So we derived first equation and we derived second equation. Then third equation. Third equation is third equation v square minus u square is equal to 2as. Derivation of v square minus v square is equal to 2as. As usually, we have to let us assume that then we know average velocity is equal to s by t. Average velocity is equal to s by t. Then average velocity again u plus v by 2 is equal to s by t. S by t. From equation 1 v is equal to u plus at. So we can write v minus u by a into t. It is 5, then it is the 6, then it is the 7. Substitute t value, substitute t value in equation 6. After that we can write, so in place of t we have to write this value, u plus v by 2 is equal to s by t value this v minus u by a. So send this that side. Simplification, you can write u plus v by 2 into v minus u by a, that equal to yes, that equal to yes. See, we must know average velocity. Average velocity is equal to displacement by time, but we know average velocity is equal to u plus v by 2. U plus v by 2, that equal to s by t equal. So from the equation v is equal to u plus at, from the equation v is equal to u plus at, then we have to know time. So send this v to right other side, become minus. Then here we have a into t, send this side as a divider. So t equal to, this is appear as like a plus b into a minus b, a plus b into a minus b. So here we can write v square, v u square minus v square, v square minus u square, or we can write this, no problem, by 2a, by 2a, right? For a understanding, this should be written as v plus u by a. Sorry, v plus u by 2 అన్నారు. It is appear as no problem. రాసుకున్న ఇబ్బంది ఏం లేదు. So a plus b into a minus b. We can write v square minus u square by 2a that equal to s. So multiply this. Means send this the other side. V square minus u square is equal to 2as, or we can write 2as is equal to v square minus u square. Last no problem. 2as is equal to v square minus u square, and v square minus u square is equal to 2as. 2as and last right here v is equal to, as usually, v is equal to final velocity. Final velocity. U is equal to initial velocity. Initial velocity. S is equal to distance. A equal to acceleration. A equal to acceleration. So this is the derivations. Derivation of three equations. Three equations of motion. Three equations of motion. So first one, v equal to u plus at. First of all, let us know what are the important terms: initial velocity, final velocity, acceleration, time, distance. These are the five are very important. So derivation of v equal to u plus at. Let us assume that a body with initial velocity u, suppose it is subjected to uniform acceleration a, to that after time t, its final velocity v. Its final velocity v. So up to here is enough for first equation, v equal to u plus 8. So we know that acceleration is equal to final velocity minus initial velocity by time. Final velocity minus initial velocity by time. So a equal to v minus u by t. By simplification we get v equal to u plus 80. So we get derived the first equation. The terms v equal to final velocity, u equal to initial velocity, a equal to acceleration, t equal to time. Second equation, s is equal to ut plus half at square. Before, the first equation of motion gives the relation between velocity and time. Then coming to the second equation, let us assume that a body covered with uniform acceleration a, final velocity, initial velocity, distance covered, as usually we have to write average velocity equal to final velocity plus initial velocity by 2. This average velocity, again we can write displacement by time. Both are same. Both are same. Average velocity, average velocity. So we can write u plus v by 2 or v plus u by 2 write it, no problem. For us better understanding, we can write v plus u రాసుకోండి, నష్టం ఏం లేదు. Right, u plus u, right, no problem, u plus u, u plus u. Then from the formula s is equal to v into t. From the formula s is equal to v into t. Displacement is equal to velocity into time, that is average velocity into time. So substitute all values. V value we know, v value, v value, substitute v value here. So here average velocity is equal to u plus v by 2 into t. Displacement is equal to, displacement is equal to velocity into time. Velocity is here u plus v by 2 from equation 1. So v is equal to u plus 8. Substitute v value here. Then simplify it. Finally we get s is equal to u plus half 8 square. These are the terms. Here one is forgot, I think. A equal to acceleration. A equal to acceleration. A equal to acceleration. Then the third equation, v square minus u square is equal to as, which gives relation between velocity and distance or displacement. Distance or displacement, 2as is equal to v square minus u square. We know that average velocity s by t. So average velocity again we know u plus v by t or v plus u by t s by t. From the first equation v equal to u plus at. So substitute and simplify. Finally we get v square minus u square is equal to 2as. So these are the very important equations for solving problems. And to know the, we have to describe the motion. I have to describe the motion by using this equations also, to know the time, to know velocity, to know the position, to know acceleration. By using these three formulas we have to solve some numerical problems. So hope you understood. So practice it. It look like very easy, but more practice is required because of some simple mathematical operations are involved here. So be careful, do practice properly, then derive the equation correctly. So be practice. Thank you.